Arc welding explained. Shielded metal arc welding.
Shielded metal arc welding is an important arc welding process because it is so widely used. It's one of the oldest welding processes, developed in the late 1800s.
It's commonly called stick welding because the electrode is shaped like a stick or rod. Shielded metal arc welding is often abbreviated SMAW. It's widely used because it's so versatile. It can be used to join many different types and thicknesses of metal in all four welding positions: flat, horizontal, vertical, and overhead. Because of this, shielded metal arc is well suited for maintenance and repair. Both the equipment and the electrodes are relatively low in cost compared to other arc welding processes. SMAW is a portable process. The equipment is easily movable, and engine-driven generators are readily available.
In this program, you'll be introduced to SMAW fundamentals. You'll get a close look at the specific types of equipment that are used to make up the welding circuit.
Let's get started. Sometimes shielded metal arc is simply referred to as arc welding, but this can be misleading. Other arc welding processes use the intense heat of an electric arc to melt and fuse metals. It's best to refer to this process by its full name: shielded metal arc welding.
The word shielded refers to the fact that during the process, the molten puddle is protected from gases typically found in the air that can weaken welds. This shielding feature of SMAW is provided by the chalky covering on the electrode, called flux. When the electrode is energized and an arc is struck, the tremendous heat burns the flux off. Some of the consumed flux forms a fume cloud that is suspended over the weld. This cloud shields the weld from surrounding gases. Other flux elements form slag. Slag starts out as a thin film or skin that covers the cooling weld and protects it. When the weld is fully cooled, it becomes a scaly covering. The slag also slows down the rate at which the metal cools, which helps to maintain the integrity of the weld.
It's the flux-covered electrode that has made shielded metal arc such an important process in industry today. Like all electric arc processes, the intense heat is created by a welding circuit. Shielded metal arc requires certain pieces of equipment to form this circuit. Let's review what they are.
They are a welding machine, a welding cable, an electrode holder, a flux-coated electrode, the work itself, a ground clamp, and a ground cable.
While there may be variations among different brands of equipment, the basic function of each component is similar. Before going through the shielded metal arc process step by step, let's look at the most important step of any arc welding process: safety.
Make sure that you have all the proper safety clothing. Never attempt to arc weld until you are properly and completely protected.
Take the time to get to know the equipment that you'll be working with. Never assume that you know how a machine operates because you've operated one like it before.
Carefully read the manufacturer's operating manual to answer any questions you might have. Instructions and procedures vary from one model to another, so be sure you have the correct manual.
Check the equipment to make sure that it is in working order.
Make sure that all flammable materials are removed from the welding area and that a fire extinguisher is at hand.
Check to see that you have a clear path for your feet while working.
Once these standard safety steps are completed, you're ready to begin the shielded metal arc process.
The first step is to choose an electrode. This is a critical factor in successful SMAW welding. Your choice will depend on a variety of factors, such as the type of metal you'll be welding. The core metal of the electrode must match the base metal of the work as closely as possible. To help you in your selection, electrodes are classified by their core material. These mild steel electrodes, for example, are the most commonly used because many SMAW operations involve mild steel-based metals.
Another factor that will affect your choice of electrode is fit-up. This describes how the two pieces of metal to be welded fit together. For example, this loose-fitting joint with several wide gaps will require an electrode that can deposit lots of metal in a short time. Certain electrodes are designed to do this.
The thickness of the base metal will be a factor that determines the diameter of the electrode that you choose.
The composition of the flux coating will also determine which electrode you'll choose. It's the flux that gives each type of electrode its shielding characteristics. The American Welding Society, AWS, has devised a numbering system to use as a guide when selecting an electrode. For example, here is a common electrode with its AWS classification number, 6010. Let's take a closer look at what each of these digits represents. The first two digits, in this case 60, indicate the tensile strength of the weld deposit in thousands of pounds per square inch. This means that this electrode can withstand up to 60,000 pounds of pressure. The third digit, in this case 1, lets you know which of the welding positions the electrode is designed for. While all electrodes can be used for flat position welding, some have special properties which make them useful for horizontal, vertical, or overhead joints. The 1 means that it is an all-position electrode. A 2 would indicate that the electrode is for flat or horizontal welding. A 3 indicates that the electrode is intended for flat position only.
The last digit, in this case a 0, indicates the type of flux coating. Included in this designation is the type of current required. 0 indicates that this electrode can be used for DCRP current only. A number 1 in this position means that the electrode can be used not only with DCRP, but with AC as well. Choose your electrode wisely. Remember, the electrode is a critical component in successful shielded metal arc welding.
After you make your selection, be sure to bring several electrodes to the workstation. This is because the electrodes will be consumed as you work. You'll need a number of them depending on the size of the job at hand. To start, set the welding machine to the proper current to be used.
Shielded metal arc welding can be done using any of the 3 types of current: DCSP, DCRP, or AC. As you've already seen, the last digit printed on the electrode will direct you as to what type of current you should use with that type of electrode. Some welding machines will have a switch that will allow you to change from one type to another. On other machines, the polarities will remain the same throughout, unless they are manually changed. This can be done by unplugging and reversing the cable connections. For example, by attaching the electrode cable at the positive terminal and the ground clamp to negative, the electrode will be negatively charged and the work will be positively charged. This setup provides direct current straight polarity, or DCSP, which will concentrate the heat in the work. Reversing the cables will provide direct current reverse polarity, or DCRP. Now would be a good time to put on your safety clothing if you haven't already.
Welding requires concentration and a steady hand. Fatigue can result in defective welds and dangerous mistakes. It's important for you to be as comfortable as possible when you're welding so you won't tire too quickly. If at all possible, move what needs to be welded into a flat position. This is the best position for accurate welding.
The next step is to prepare the work itself. Make sure that the area on the piece to be welded is as clean as possible. Remove rust and paint with a wire brush.
You are now ready to set power off levels. Set the amperage dial to coincide with the manufacturer's instructions. Next, check the jaws of the ground clamp to make sure they're free of rust and dirt. Then, attach the clamp either to the work or to the work table. Wiggle the clamp back and forth a few times to ensure good contact. With the welding machine still turned off, place the uncoated end of the electrode between the jaws of the holder. Good electrical contact is important, so check to be sure that the jaws are clean. Moving the electrode from side to side in the holder can help to increase electrical contact. It also ensures that the electrode is firmly seated between the jaws. With the electrode in place, grip the holder lightly in whichever hand is most comfortable. Experiment with different hand positions to find one that will work best for the job. Some welders bend the electrode near the uncovered end to achieve a more comfortable work angle.
You are now ready to turn the power on. Once the power is on, there are 4 core skills to master as you do shielded metal arc welding. They are striking the arc, setting and maintaining the proper arc length, holding the electrode at the proper angle, and using the proper speed. To strike the arc, use 2 hands to position the tip of the electrode so that it is at a slight angle, no more than 1/2 inch above the weld start point. Lower your helmet with a quick nod of your head. Striking an arc is like striking a match. Rotate your wrist so that the electrode brushes against the work and starts the arc. This must be done without marking the work surface with inaccurate arc strikes. If you have difficulty striking an arc, check to be sure the ground clamp is securely attached.
Immediately after contact, raise the end of the electrode slightly to establish an arc. Dimensionally, this arc length should be equal to or slightly less than the diameter of the electrode being used. If the electrode is not raised quickly, it will stick to the work. This will cause a short circuit and the electrode will heat up. Twist and bend the electrode to break it free. If the electrode is stuck fast and does not break away, quickly disengage the electrode from the holder. Or shut the power off to stop the current flow. Let the electrode cool, then break it free by hand. With a little practice, you can learn to strike an arc without the electrode sticking. Because the electrode is consumed, you'll have to feed it towards the work surface while traveling along the joint in order to maintain the arc length. As you gain experience, you'll learn that the quickest way to determine if the arc length is correct is by listening. When the proper arc length is maintained, you'll hear a continuous high-pitched crackling sound. A humming sound indicates that the arc length is too long. Arcs that are too short make a popping sound and may flash on and off, indicating the electrode is striking and short-circuiting to the base metal. The important thing about arc length is that it establishes the basic voltage across the arc. Longer arc lengths increase arc voltage, while shorter arc lengths decrease the voltage.
The next SMAW skill to focus on is holding the electrode at the proper angle while welding. With most electrodes and welding in the flat position, the electrode should be angled no more than 15 to 20 degrees from the perpendicular. This slight angle allows the force of the arc to keep the molten slag out of the puddle and improves visibility of the joint as it is being fused. Shielded metal arc welding is most often done using a backhand motion, with the electrode pointed in the opposite direction to which it is traveling along the joint.
The 4th core skill to master as a shielded metal arc welder is finding the proper speed. Welding should proceed at a speed that keeps the center of the weld crater about 1/4 of an inch ahead of the following wave of slag. In this way, bead appearance will be uniform in width and in ripple formation.
While mastering these 4 core skills at the work table, you must also stay aware of the amperage level registering on the welding machine.
If the sound does not adjust as you're increasing or decreasing the arc length, check the amperage. This can also be done by checking the width of the molten crater right after the arc is struck. It should not be more than 2 electrode diameters wide. This 2 diameter width should be maintained without excessive travel speed or side-to-side movement of the electrode. If this is the case, you know that the amperage is at the correct setting. After the weld is finished, it will need to be cleaned by chipping away the slag. This can be done using a chipping hammer. Slag removal presents a danger to the eyes. Safety glasses worn under the welding helmet are a must. Use the hammer in a way that directs the hot slag fragments away from the body and face. After the large pieces of slag have been removed, use a steel brush to further clean the weld. When all welding is finished, be sure to turn off the machine and clean up the area. Be sure to discard all electrode butts in a metal can. Also, recoil the cables.
You've now been introduced to the procedures for shielded metal arc welding. It's important for you to keep practicing the core skills. Over time, you'll perfect your ability. You've chosen an important field to be a part of because so many areas of industry depend on welding processes. If you have any questions about shielded metal arc welding, be sure to view this program again.